These are Unit 7, Day 8 notes, and we're closing out the unit here with factoring these higher degree polynomials with solving them. So we've been down this road with quadratics before. So let's just refresh our memory on how to solve quadratics. So question 1 here says Polly needs to do 2 problems for his homework. Solve each problem for x. Show your work and explain how you got the answers so that Polly would understand. So these are both quadratics, and these are both using techniques that don't involve factoring using the star method. So for instance, in this expression here in A, we only have the variable listed in one location, so it's easy enough to isolate. We're just going to add 100 to both sides. And we're going to get 2x squared equals 100. Then we're going to divide by 2. We're going to get x squared equals 50, which means, and then we square root to get rid of the power. So we have x equals plus or minus the square root of 50, which we could simplify if we wanted to. And those are the 2 solutions that work for that quadratic. In this quadratic, we noticed that if we would try a star method, it wouldn't work. There's nothing that multiplies to 16 and adds to 4, if you think about it, right? If we look at 1 and 16, 2 and 8, and 4 and 4, none of those work. So the next easiest thing to do would be to use the quadratic formula. So we could use, there we go, where we do opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we know a is equal to 1, and b is 4, and c is 16. So we have the opposite of 16 plus or minus the square root of 16 squared minus 4 times 1 times, ooh, mistake, b is not 16, b is 4. There we go. And then c is 16. There we go. All over 2 times a, which is 2 times 1. And so we have opposite of 4 plus or minus the square root of, and when we look at, oh, that's not what I meant to do. Hold on here. Let's get my notability back up here. There we go. When we look at simplifying the stuff in that radical, we have 4 squared minus 4 times a, which is 1, times c, which is 16. We have negative 48. Negative 48 all over 2. So that looks like it's complex. And in this situation, I'm going to simplify the square root of 48. So 48 is 16. 16 times 3. That's what 48 is. And 16 is a perfect square, so that's going to come out as a 4. So this is going to be 4 root 3i over 2. So if you just kind of piecing this together, 48, 16 times 3, 16 comes out as a 4. The negative sign, square root of a negative, is the I. That's kind of, and then if I divide both of those by 2, it's minus 2 plus or minus 2 root 3i. So there's the answer to that. So that kind of goes over all of the non-star skills in 2 problems, which is a lot of skills. We did the isolate x sort of method because x was only listed once. This was not factorable using the star, so I just jumped right to the quadratic formula. I could have tried completing the square or something, but nah, that's okay. And end up having a complex radical, little radical simplification there. You can either choose to do that or not. If we look at the second question, it says Polly thinks quadratics can be solved by factoring. Is this true? And obviously this is not true. There are some that are not factorable. And there are some that are just easier to do without factoring. Like, we could factor A, but it was just easier to isolate x squared algebraically. So, sometimes we need the quadratic formula, or easier solutions exist other than factoring. So, but the idea is that, we basically, I guess the idea is that if we're setting this equal to 0, we have to start solving it for those values of x that make that statement true. So, so that's what we're going to do here in 3. It says, let's show Polly how we can use the idea to solve polynomials. So when we talk about solving the polynomials, we're talking about taking that polynomial and setting it equal to 0 so we can find those x-intercepts. So this one says we have the polynomial 2x cubed minus 6x squared minus 100x plus 300. We know we have a factor of x minus 3. Find all solutions to the polynomial set equal to 0. And so the first thing we need to do then is, because this is a higher, this degree is higher than 2, right? It's a higher order polynomial. It's not a quadratic. The first thing we need to do is take that known factor of x minus 3 and divide it out of the existing polynomial. And so if it's asking us to factor, so kind of the implied idea here is, if it's asking us to factor, if it's telling us, let me rephrase that, if it's telling us that it has a factor, then that factor should be going into that product, that polynomial, without a remainder. So, so we know we have 2x cubed. We color code this. The product is blue. 2x cubed. We have 2x cubed is that upper left-hand box. We know that this box is going to be 300 here, but I'm going to refrain from putting it in. Okay, let's play the fill in the blank. So this needs to be a 2x squared. And that makes this lower box a minus 6x squared. And we know that this lower box and its diagonal make up like terms. And ironically, they have to add to negative 6x squared. Very interesting. So what that means is that we need a 0x squared here. We don't need anything because we already have what we need. That's kind of cool. So we just put a 0x squared there. So what that means then is up here, this must be 0x, this next fill in the blank. And if that fill in the blank is 0x and we multiply down, play the multiply game, right, then this must also be 0x, or I guess we should say 0x, because we're trying to make the negative 100x term. So let me just backtrack, right? We made the negative 6x squared. There we go. Now we're trying to make the negative 100x squared. So these two are like terms, and they need to make negative 100x. So this must be negative 100x here. So this fill in the blank up here then is negative 100. And when we do the multiply, we get positive 300, and there it is. All right, we get that positive 300, and that matches that final term. So we know we have no remainder, which is what we expect, right? Because we know that x minus 3 is a factor. And so we know then we have that polynomial is factored into x minus 3. That's that we were given, times 2x squared minus 100 equals 0. So that's the factored equals 0. So that's the factored, that's the polynomial written as a product of the factors. If you notice the 2x squared minus 100, this factor here is this problem up here. So to solve this, then we set each one of those equal to 0. So we have x minus 3 equals 0. We add 3 to both sides. So we have x equals 3. And then I'm not going to go through all the steps, but we have 2x squared minus 100 equals 0. And that we know is x equals plus or minus the square root of 50 from above, from number 1a. So those are the two answers. So let's just take a look at this graphically. Those are the zeros. We should be able to see those as x-intercepts when we graph this. So clear that out. So 2x cubed, there we go, minus 6x squared minus 100x plus 300. So if we graph that, there is the 3, and now we're looking for plus or minus the square root of 50. So think about the square root of 50. 49 is a perfect square, and that's plus or minus 7. So we must be somewhere close to 7. So here's that 3. Here's the 707, so that's the positive square root of 50. Here is the minus 707, so it's negative root 50. So that's what that polynomial looks like. We can kind of swoosh it down so you can see the hills and valleys. Not that we're concerned about them, but there they go. That's what it looks like. So that would be a fully factored, that would be the that polynomial fully factored and solved. So we see, I guess I got rid of that a little soon. We see 3 intercepts, and no, because we found all 3 of them in that solution. So we found that by solving 3a. Okay, so let's try one more. So we have this function. So now we're kind of giving you this in a little bit different information setup. It says we have the function this, and it says find all zeros. And we know we have 1 0. It says this, we have 1 0 of x equals negative 1. So what that means, excuse me, get just a little visual picture here, right? At negative 1, we know that we are crossing the x-axis there. And so that being the case, then the factor is x plus 1. So the factor is the expression, this expression where negative 1 makes it 0. So we know we have a factor of x plus 1. So when we set up, because it's a third degree polynomial, we have to set up the area model to divide out that first factor. So this is x plus 1 here, x plus 1, and we know this first term is x cubed, and that starts us off. Now we can play the fill in the blank game. Right up here we need an x squared. Now we're going to play the multiply game. X squared times 1 is x squared. Now we have to play the like terms game. Let's combine these like terms to make 5x squared. So we have 1x squared, so we must need 4x squared. Now we're back to the beginning, right? We're going to do it all over again. We're going to play the fill in the blank game. This must need to be 4x. Now we're going to play the multiply game. 4x times 1 is 4x. And then we have to play the combine like term games to get the next term in the product. which is 20x. So if this needs to be 20x, then we need a 4x and a 16x to make 20x. And then we start the process all over again. We play fill in the blank. This must need to be a 16. We play the multiply game. This times this is 16. And we know that we should have a 16. We could have filled this in from the beginning. I think I used the wrong highlighter there. Let me get rid of that highlighter, make it blue, because products are supposed to be blue. It's my own little color coding. And so we make the 16 at the end here, so we know we have no remainder, which we shouldn't, because we were told that x equals -1 is a 0. So we know that this factors into x plus 1 times the quantity x squared plus 4x plus 16 equals 0. And it's looking like we set you up intentionally so that we could grab the solution from 4b. Okay, I guess. So solving this now, we have x plus 1 equals 0, which means we get back what we started with, right? Which is this, right? They told us one of the solutions already. And then this other solution, x squared plus 4x plus 16 equals 0, we know we have the solutions -2 plus or minus 2 root 3i for those two solutions. And so when we look at that particular one, let's go ahead and graph this one. Because it has complex solutions, why don't you I'm going to kind of pause for a minute as I'm typing this in, speculate how many zeros we're going to see, knowing that we have some complex solutions here. So think about that while I'm typing it in. Okay, I got x cubed plus 5x squared. I almost forgot my power. There we go, 5x squared plus 20x plus 16. Okay, so if you thought about how many x-intercepts you see here, we're kind of answering the next question here. So if we know it's a third-degree polynomial, so you might guess 3, but we have 2 complex, so we only have 1 real. So we would expect to only see this cross at one location, which is that -1. And notice it doesn't cross anywhere else because the other 2 zeros are complex. So we have 1 intercept. How about we'll just say ONE1. There we go. 2 others are complex, so they don't appear on the real coordinate system. That's the tricky part. That's why we say that the degree is at most the number of x-intercepts, but there could be fewer intercepts. There we go. Okay, so looking then at, let's just take a look at number 1. So just to kind of look, this is a table of selected values is given for the function. Solve this. This is kind of an interesting one. So solve this quadratic here. So they're giving you a table, and you might think, well, why are they giving me a table? But the idea of giving you the table is they can hide the one of the factors in the table. So we know that a factor is crossing the x-axis, and crossing the x-axis is when y equals 0, right? So this is the x-intercept. This is one of the x-intercepts here. And so what that does is it sets you up. If 8 is an x-intercept, then we have a factor of x minus 8. And so we can set up the model then to divide out that factor. and x and minus 8. And so we know that we have an x cubed here as our first square. We know we're going to have a 192 in the last box, but let's let this play out. Okay, so let's play fill in the blank. This needs to be an x squared. I'm going to move this down a little bit. There we go. And then let's play the multiply game. This times this is negative 8x squared. Okay, now we have to play the combine like term games. So we've got this term and this term is going to get us this in the product. So I need a plus, oops, excuse me, I put that in the wrong spot. It needs to make a minus 6x squared. So this must be a plus 2x squared. And then we can start the process all over again. We can play the fill in the blank game. So this needs to be a 2x plus 2x. Then we can play the multiply game. So that looks like negative 16x. Negative 16x. And then we can play the fill in, or the combined like terms game to get that next term in the product. So we need minus 40. So that needs to be minus 40x. I already have minus 16, so I must need minus 24x to make a minus 40. Let's see, 24, 34. Yep, that's it. That's what I need. Okay, so, and then we can start the process all over again. This is minus 24, fill in the blank. And then multiply minus 24 times 8. Geez, I don't know. I'll just come over here and go 24 times 8, that's 32, that's a 2, carry the 3, 16, 17, 18, 19, 192, yes it is, yay, plus 192. So we end up with that last term, which is good. That tells us there's no remainder, which there shouldn't be because we were dividing out a factor. So this is kind of the meat and potatoes here, I like to call it. Right, this is really getting at the skill here. So we started out by dividing out x minus 8. And that factor was given to us in the table as a 0. And we ended up with x squared plus 2x minus 24 as the remaining factor. And that is factorable. So, you know, the analogy I'm going to throw out here is let's say we started with a number like, I'm thinking here, let's say we started out with a number like 18, and you said, oh, well, that is 2 times 9. And I'm like, cool, I gave you a factor of 2, you found the factor of 9, but hey, this factor of 9 is still factorable, right? We can still say, well, that's all fine and good, but this is really 2 times, and then 9 we can factor into 3 times 3, right? We call this a prime factorization when these are all prime numbers. That's what we're going after, is we're going after breaking this down and factoring it as far down as possible, so that it's not, there aren't any other factors to be factored out. So they must be all prime. So this is factorable, and this is where the star method comes in. So we could use the area model here if we wanted to, but I would just, if you want to continue the area model, you go right ahead. But I'm going to go ahead and do this, try the star method here, see if it works. So we multiply to 24 because we have 1 times 24 is 24, excuse me, and we add to 2. So our factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and there they are. We need a 4 and a 6, and we need a positive 2, so I need a positive 6 and a negative 4. So now I know that that factors into x minus 4, x plus 6, and that's just the orange part. I still have the x minus 8 equals 0. So now I can fully solve this, and we know that this solution is x equals 8. And then these solutions, the 0 is x equals 4 here, and the 0 is x equals negative 6. So if we would graph this polynomial, there we go. If we would graph this one, it would be x cubed minus 6x squared minus 40x plus 192. It's a really tall y-intercept. When we graph that, we can see here's the first 0 at negative 6, and here's a 0 at positive 4, and here's the 0 at positive 8. So that's what that's kind of, like I said, it's the meat and potatoes. It's where we can use other factoring methods after we start out with the area model to get that degree of 3 broken down. Okay, so our learning targets then are going to kind of be being centered around that. The first learning target is just identifying factors or we call them zeros. Call the solutions to those zeros. And so the way we can identify them is we can identify them on a graph. We can identify the zeros. We can identify them in a table. That again is a 0, which means we have to place it into its factor expression. And then we have to turn the 0 into its factor expression. And then we can start the process of the using the division, the area model. Okay, learning target 2. There we go. Learning target 2 is the meat and potatoes, right? It's the solving the polynomial. So the first thing we're going to do, number of solutions equals the degree, right? Number of solutions equals degree. Some solutions might be complex, we don't know. But the first thing we do is we use area model. Whoops, I spelled area wrong. There we go. Area model. And using first 0 that we found from learning target number 1. And then take that result and factor using any method after the area model. And then solve. You got to solve, right, all those factored expressions. So solve factored expressions so that you can get all of your zeros. All right, so as we look at the homework, then you can see that each one of these homework problems, going into the next page, they start out by giving you a single factor, or on the second page they start out by giving you a 0, and you have to make that factored expression, and then you're off and running with the